So yesterday I asked you guys to complete the laboratory, right?
Sure.
Hopefully you completed that. It's due on Canvas, yep.
Tonight or yesterday?
Tomorrow.
Oh, okay.
And then I told you please to go through these four corner diagram pages. There's 3 or 4 of them. And this is basically a lot of extra practice. If you can do this practice, then you're not going to have any trouble on the test. This is one of the harder things on the test. So if you prepared yourself for this, you're probably pretty good. The test is actually the final exam day.
Wait, so is the final exam?
It is.
Okay.
Yep. So if we take a look, and it is optional, but if we take a look here, you should have gotten these answers. Down here, it says determine the pOH if the hydroxide ion concentration is this. So the pOH to the hydroxide concentration is like the pH to the hydrogen ion concentration. So we have the hydroxide ion concentration. We need to take the negative log of that. Negative log 0.763. I have calculators on the wall if you need one. Oops, I did not press the 7 hard enough. 0.763. Boom. So we get the pOH of this being 11.75. I'm sorry, not 11.75. I can't read. With these glasses, it's hard to see sometimes. That didn't make sense to me, so I rechecked, and it's not 11.7. It's negative first. Instead of being 11.75, it should be what? 0.1175, which makes a lot more sense to me. Now, a hard thing, and we went over this yesterday, but a hard thing is this is the pOH. So is this an acid or a base? If the pOH is 0.1175. It's a pOH. So it is a base. Remember, if it is the pH less than 7 as an acid and greater than 7 as a base, if it's the pOH less than 7 is a base and greater than 7 is an acid. That's why I suggest if you're given one and you're not sure, you're sitting there thinking, just go ahead and find the one that you know. If you're given the pOH and you're like, oh, wait, how does that go? It's reverse or opposite or whatever. Don't worry about that. Just find the pH and then go with what you know. We make that our new slogan, go with what you know. So 0.333. So we take the negative log of 0.333. And we get 0.47, or actually 0.48. Acid or base? pOH is 0.48. pOH is less than 7, it's a base. Yep. Determine the pOH if the pH is 4.9. If the pH is 4.9, is it an acid or a base? Acid. So what is the pOH going to be then? Greater than 7. So it's going to be 9.1. Nice. And the pH is 2.3. Acid or base? (2.3) pH is an acid, and 11.7 would be the, isn't that right? Yeah. 11.7 would be the pOH. So E, pH of 4.9 is acid. C, pH of 5 is acid. F, pH of 2.3 is acid. Ooh, easy enough. Then they wanted you to find the hydrogen ion concentration given the hydroxide ion concentration. So basically with that, you got to take 1 times 10 to the negative 14 and divide what they give you, divide 1 times 10 to the negative 14 by that. So 1 times 10 to the negative 2, then I can't do that in my head. So we take 1 times 10 to the negative 14 divided by 2.4 times 10 to the negative 6th. We get 4.2 times 10 to the negative 9th. Here, same thing, 9.8. Now, I know this seems repetitive, but we do need to put these in the calculator a few times so that we get this down. Otherwise, you're not going to have it down during the test time. We get 1.0 times 10 to the negative 12. Divided by 0.359. 2.8 times 10 to the negative 14. That's it. Then there's a bunch of miscellaneous problems. This is what you should definitely practice. If you have not completed these, do that, and I'll post the answers to this either on the Zoom or tomorrow. Then there's more practice here. Same thing. The only difference here is this is from last week, the video. To find the hydrogen ion concentration of a weak acid or to find the hydroxide ion concentration of a weak base, you have to be given either the Kb or what we call the Ka. Once you're given that, you take, to find the hydrogen ion concentration, you take the Ka times the concentration that they give you here, and then you take the square root of that. That's what gives you the hydrogen ion concentration. They get tricky sometimes, and they're like, here they're asking for the hydrogen ion concentration, but what if they ask for the pH? Well, you'd have to do all this work and then take the negative log of that to get the pH, which I've counted here. Good, 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 good. That brings us to today's lesson, known as Bronsted acid-base theory. So we know the Arrhenius acid-base theory is quite easy. You take and you find that H is an acid that has an OH at the end, it's a base. The easiest way to look at things. Problem is, some things like ammonia or like this right here, this doesn't have OH. How can I classify that then? Well, that poses an issue. So Bronsted found that somehow this does act as a base. We need to figure out how. So they redefined the acid as a hydrogen ion or H plus donor. They redefined the base as a hydrogen ion or H plus acceptor. Now the cool thing is that an acid will form a base, because the only difference between an acid and a base is one hydrogen. So if I'm an acid and I lose a hydrogen, I give that hydrogen to something else. Well, if I take that hydrogen back, then that's the opposite of what I just did giving it. Instead of it being an acid, then I would act as a base if I'm taking that hydrogen back. That's the thing. So if we take a look, HS negative becomes S2 negative. We lose an 8. What's the charge of 1 8? Plus 1. So if we lose with plus 1, we become a negative 2. Here, in H2, negative, gained an H. It also lost its negative because it gained a plus 1. So acids lose H's and become bases. Bases gain H's and become acids. Pretty cool. So let's look down here. HF versus F negative 1. Are these conjugate acid-base pairs? If HF acts as an acid, what will it form? If HF loses an H, it will form F what? Nope. OH is not coming from anywhere. But the H has a what charge? 1. So this won't be just F, it'll be F what? Negative 1. Because here it's 0. So if we take a look here, yes, these are conjugate acid-base pairs. How about this? HNO3 becomes NO2 negative. Is the only difference between HNO3 and NO2 and H? The only difference between HNO3 and NO2 and H, or is there another difference there? Well, the charge is part of that H. Is there any other difference between the H and the charge? Just like define what's wrong with this picture thing, right? They give you a picture and then you just look. Is this and this the same minus an H in the charge? What else is messed up? Yeah, right. There's 2 oxygens and there's 3 oxygens here. So this one won't work. These are, you guys, these seem harder than they are. So take a look here. We have these following reactions. We're going to identify conjugate acid-base pairs. So CN becomes HCN. Did it donate an H or receive an H? Receive. So receiving means that CN is a base. H2O became OH negative. Did it donate or receive an H? H2O became OH negative. Did it donate or receive an H? Donated. So that is an acid. But keep in mind what I said on the front page. An acid forms its conjugate base. So when it loses that, it forms what we call the conjugate base. A base forms its conjugate acid. The only difference between this and this is an H plus. The only difference between this and this is an H plus. This received the H plus, this donated the H plus. So up here, you just tell whether it's an acid or a base. NH4 plus 1, acid or base. It donated an H, right? So it's an acid, good. And here H2O became H3O, so what did it do? H2O became H3O, so did it donate or receive? Received, that makes it a base. So the acid forms a conjugate base, and the base forms a conjugate acid. Right. Down here, write the conjugate acid of the following. So remember, these are bases, so they want to accept an H. So ClO4 has 0 H's right now. So what will the conjugate acid be? It's a base, so is it accepting or donating an H? Bases receive or donate. Receive, so how do we draw an H? It's 3 lines, right? H, and then ClO4. Why do I lose the negative sign? Because the H has a charge of what? 1, right? The H has a charge of 1. Down here, it's just the opposite. NH3 is acting as an acid. So what am I going to do to the H's here? I'm only dealing with 1 H at a time. But what's going to happen if it's acting as an acid? Is it going to receive another H or lose an H? It's going to donate an H. So it's going to become NH instead of 3 H's. Now I only have 2. What is the charge when I lose an H? Negative. That's it. I'd like for you to work down to number 30 on this. If you weren't following along, I mean, this is pretty easy stuff. We're just talking about moving H's and 1 at a time. That's it. 1 H at a time. Don't forget that an H does come with a +1 charge. So if you lose an H, you become negative. If you gain an H, you gain a positive. Have a great day. Take care.